video we are going to learn about the applications of electrolysis. See, we can learn so many things, but we should know where to apply, what is the application, what is the use. So without that, just learning everything is a waste. Okay, so there are three main applications that we need to know. The first one is electroplating. This is the first application of electrolysis. Widely used is electroplating, and the second one is electro-refining. This is for the metals to be refined. Again, we need it, very widely used it is. And then of course for extraction of metals, which is called as electrometallurgy. So coating of a superior metal over an inferior metal is electroplating. Refining is to purify a metal to the purest, that is 99% or 99.99%. Electrometallurgy is something that through which you extract the metals which are highly stable for any other treatment except electrolysis. Now we move on to electroplating. The first one is electroplating. What is electroplating? Plating means what? It is actually called or means coating. Okay, so there is some coating that you are giving, a thin layer of coating that is given in the presence of electricity. And where is it given? It is given over a base metal. Okay, so that base metal is highly reactive base metal, and over that you have a non-reactive or unreactive superior metal, and that is called electroplating. So the definition goes this way: deposition of a less or non-reactive superior metal, okay, over a more reactive base metal. We should not forget the word electro. So it is happening in the presence of electricity or electric current. This is the definition of electroplating. So what are the important things that we need to make a note of? Here it is, a superior metal is involved. Okay, and over what is it being coated? It is coated over a base metal and in the presence of electric current. So this only is called as electroplating. And usually the superior metals could be of different types, say silver, gold. These are superior metals that we use, or sometimes we use nickel, we use chromium to prevent rusting and other things. And the base metal is usually iron, steel, copper, brass. Okay, so that gives you an idea of electroplating. Now we move on to the conditions for electroplating, and each condition, see, when you have a condition, you have to get up early, you have to go for a walk, that is a condition. Why are you going for a walk is the reason. Okay, why are you going for a walk? You go for a walk so that you keep yourself fit. Like that, there are conditions for electroplating with proper reasons. Every condition has a reason. So the first condition, before we start electroplating, before you plate or you paint something, remember, the article to be electroplated should be clean. Usually when you paint a surface, when you paint your house, you know that you clean it extremely well before you start, otherwise the paint would just take away the dirt and the dust and there would be patches that are seen. So first and foremost the article should be cleaned up. After that, what happens here, we can have an idea from this that the superior metal, here in this case it is nickel plating, and the superior metal makes up the anode. Okay, so the anode is made of superior metal, and this superior metal electrode is also active. So when it is active, what happens? It releases its ions. See here in this case, nickel is the anode, that is a superior metal, and because it is a superior metal, it is releasing nickel ions. Okay, so because it is an active electrode, it's releasing its own ions. Okay, so cathode is made of the base metal. Okay, so this will be inferior, we can call it inferior metal compared to the superior metal. It's definitely its value or worth is inferior, and this cathode is made of this because according to our mechanism of electrolysis, all cations will move and get deposited at the cathode. So if we are going to have cation here, that cation can only go towards the cathode. So cathode should be made of the base metal. Okay, then the third reason should be that the electrolyte should have a high concentration of the superior metals ions, high concentration of the ions of the superior metal, because even if the position is different, the concentration can always pull it and get itself deposited. Okay, then the fourth one is it should happen at a prolonged time and low current. Low current should be used for a prolonged time. Okay, it is like supposing when you see your mother preparing chapatis, if she is going to keep the flame at the highest, it will be burnt but it will not be cooked. Okay, so the deposition or the cooking process is not even. Like that here also, if it is going to be shortened and a high current is used, then there is uneven deposition. The last one is we have to use direct current and not alternate current, AC, but only direct current. So now coming here, anode is active. So what will it do? It will ionize and release ions. That is why we need the anode to be made of the superior metal. Cathode is made of the base metal. Why is it made of the base metal? Because all cations are deposited or discharged at the cathode. That is why cathode should be made of the base metal. Electrolyte should have high concentration of the ions. This enhances the deposition, means increases the deposition. Prolonged time and low current results in smooth deposition. Okay, direct and not AC, because AC or alternate current would result in ionization and deposition. So what will happen? It will get ionized, it will get deposited. it will get ionized, it will get deposited. Ultimately, it's not going to go anywhere. So that's what will happen if direct current is not used and alternate current is used. So these are the conditions that we have for each of these things. These are the reasons that we have. We have seen the definition, we have seen the conditions, we have seen the reasons. But why are we doing this electroplating? We need to know the main reasons for electroplating. There are two main reasons. The first one being, if you take iron taps, okay, iron will rust in the presence of two factors, moisture and oxygen. And if a tap is going to be made of iron or steel, and if you are going to use it with water all the time and oxygen in the air, it's going to rust and you'll be running to the plumber all the time, hardware shop and everything. So to prevent rusting and corrosion, that's the main thing we do electroplating, to prevent rusting or corrosion of metals. So whenever a base metal is coated with metals like nickel or chromium, it can prevent that from rusting. So that's the first one. Second one is to look attractive. Today we have a wide variety of so many imitation jewelry that you get. It is all gold plated, silver plated, but the base metal being iron or tin or brass or alloys, okay. So to look attractive. Both these reasons are prime reasons for electroplating. Let's look into nickel plating or electroplating with nickel. Now here we have an article that's made of brass, it's a bell of course, and we have a nickel anode. So a nickel anode, in this nickel plating, the anode is made of the superior metal, that is nickel, and this nickel is active in nature, okay. Alright, what is the cathode made of? Cathode is the base metal, and that is the article to be electroplated. Alright, now we move on to the electrolyte. What is the electrolyte? It is aqueous nickel sulfate. This is the electrolyte. Aqueous nickel sulfate is the electrolyte. Now when we go into the reaction part, let us take the dissociation reactions. What all are present here? Aqueous means water and nickel sulfate is there. Therefore, water dissociates into H plus and OH minus, and nickel sulfate dissociates into nickel ion and sulfate ions, okay. Actually traces of sulfuric acid is also added, but we are not taking that right here. Now let's go to the reactions at cathode. As we know, cations will move towards or migrate towards cathode. What are the cations present here? H plus and nickel will migrate to cathode, okay. Then which one would be discharged? Nickel would be discharged. It adds on 2 electrons and forms nickel metal, okay. Now going to reactions at anode. What are the ions here? Both the ions will migrate to anode, but remember, what is this anode made of? Nickel, which is an active electrode. Okay, so none will be discharged. Instead, this nickel will lose 2 electrons and form nickel ions, which will be lost in, as you see in the diagram. From the anode, nickel ions get ionized and they are getting deposited at the cathode. So that's what is happening at the anode. So now if we move on to the product, what do you get? You will get a cathode mass will increase and cathode is coated with nickel. This is what happens at the product side. So as slowly it goes, let us see the final observation. How this nickel plating goes about. What has happened? The anode is slowly getting ionized. Therefore, the size of the anode mass decreases. Okay, so now initially it is so big, so huge, but slowly after the plating gets over, this anode mass would decrease and it becomes thinner. So that's what happens with the anode, and slowly this cathode is getting plated or coated with nickel, and nickel is a silvery gray metal that gets deposited this way. So this is the final thing. So cathode mass increases. Okay, so these are the two things that happen with anode and cathode by the end of electroplating with nickel. So we have just done with electroplating of nickel. Stay tuned to watch electroplating with silver. Hello students, in this we are going to see the electroplating with silver, which we can also call it as silver plating or electroplating with silver. Now in this case again, let us see what the anode is made of. It is made of, because we are going to coat it with silver, anode will be made of silver, pure silver block. Okay, and we should not forget that this anode is active. It's an active electrode. Next we move on to cathode. What is the cathode made of? The article to be electroplated. In this case, it is an iron spoon. So let us take the cathode to be an iron spoon. This is the base metal. Okay. Next will be what is the electrolyte. When you come to the electrolyte, we know that it should contain ions of silver because it has to be coated with silver. So we take aqueous sodium silver cyanide, or it can also be called sodium argentocyanide. Why the name argento? Because silver's Latin name is argentum. Okay, so here Na, silver and cyanide, this is a complex salt and it's in the aqueous form, means water is added. Okay, so we go to the dissociation reactions. Two things are involved here. First one is aqueous water and sodium silver cyanide. So the sodium silver cyanide, when we break this, it will dissociate into sodium ion plus silver ion plus there are 2 ions of cyanide. So 2Cn minus. Alright, next we should not forget about water, which dissociates into H plus and OH minus. So these are the dissociation reactions. Now going to the reactions at cathode. What are the reactions at the cathode? What are the ions that will go? Now you have a real race. What are the ions? There are 3. You have sodium, you have silver, and you have hydrogen. Okay, again our electrochemical series would come into the picture. So here you go, you have sodium right on top and you have silver right below and hydrogen is somewhere here. So 3 cations, sodium here, hydrogen ion here and silver. Because silver is the lowest in the electrochemical series, silver will be discharged. So that is selectively discharged. Therefore, migrate to cathode. Silver ion discharged. Why is it discharged? Because it is lower in the electrochemical series. Okay. How is it discharged? It has only running short of 1 electron to get silver metal. So this is the product at the cathode. See, all these things will go and they will get deposited at the cathode. Now going to the reactions at anode. What are the ions that would go? Again we have many things here, cyanide ion and hydroxyl ion. Both of them would migrate to anode. But we must also remember, even though both are migrating, which one would be discharged? We already have silver, which is an active electrode. Okay, so none will be discharged. Instead, this being active, silver would lose 1 electron and become silver ion. Okay, and this is how the reaction happens. So from the anode, it just ionizes into silver ions and these silver ions get deposited at the cathode. So finally, after a period of time, what happens is this steel or iron spoon is plated with silver. Okay, so it becomes silvery. At the same time, because it has come from there, this becomes smaller in size. So it reduces in mass. So these are the observations that we see. So let us sum up the observations here. So there is the article which is at the cathode gets coated with silver. So when you have a coating with silver, the mass of this cathode will increase. So the mass increases. Okay, that is the first thing that we see. The second one, of course, anode diminishes in mass. By the end of the experiment, anode will diminish in mass. So that is the next observation that we see. So these are the 2 observations that we have for silver plating. One important thing that we need to make a note of is silver nitrate is not used as an electrolyte. See, silver nitrate is very easily available and it's highly soluble in water too, but it's not used as an electrolyte. Why? Because sometimes some of the things may look very nice, but then they are not always good, okay, like that. This silver nitrate, when we use, it results in fast dissociation. Very fast, the dissociation goes very fast. And if the dissociation is very fast, will there be an uniform deposition? No, okay. Fast dissociation resulting in uneven deposition. After spending so much on this silver, which is a costly metal, we can't afford to have an uneven deposition and doesn't look nice, okay. So therefore, we do not use silver nitrate, but instead we use aqueous sodium silver cyanide as the electrolyte. So this is the electrolysis that happens, electroplating that happens with silver. So we can call it as silver plating.